Good day everyone, especially to the panel of judges. I am Nelborn C. Cuenca of Katipunan National High School of Zamboanga del Norte Division. Today I will be presenting to you our science intervention material entitled Science Connect 4 Game Challenge. My co-authors are Sir Luigi Tuiza and Ma'am Alma Tabaza. The topic of our scene is on projectile motion with the target competency investigating the relationship between the angle of release, the height, and the range of the projectile. Actually, this scene was part of our action research. This was used in our action research that eventually won in the last 18th Science Quest. It was presented by Ma'am Alma Tabaza. And with regards to our game, why Connect 4 game? Various studies mention of the advantage of games in the classroom. Boyle 2011 mentioned the role of games in triggering discussions and learning concepts among students following a gameplay. According to Kim et al. In 2008, in their study of using metacognition strategy in game-based learning revealed that discussing gameplay with peers during break sessions positively affects social problem-solving ability of the students. And in Hill and Kemp 2018 recognized the potential of Connect 4 to be used in the future problem-solving researches as a reliable elicitation tool of insight and research and search experiences for both negative and positive solving. The study also revealed that Connect 4 may seem to offer more through-to-life solving exercises than other paradigms where a series of problems are solved. What is Connect 4 game? The game is actually derived from Connect 4 or Link a 4 game, of which the goal is to build a row of 4 chips in any direction, either diagonal, vertical, or horizontal. However, for this particular game, the objective is to get the highest possible score. And if one player completes 5 in a row, the game will end and the player with the most score will win. Only 2 players can play the game. How are you going to play the Connect 4 game? Here is our board. Lay the game board on the table. See the next page. Place it between opponents. One opponent will take all the chips of one color, red or blue, and the other opponent takes all the other colored chips, blue or red, and decide who plays first by tossing a coin. And on your turn, place one of your chips to any circle on the board. With regards to the CFG chips, these are the chips. And each player will have 21 pieces of chips. Each chip contains numbers starting from 0 to 6, of which the player will compute for the height and the range respectively. Here are some of the rules in playing the Connect 4 game. The game will be played only by 2 players. The game ends when a player can make 5 in a row, either diagonal, horizontal, or vertical. And the player who got 5 in a row will be given 100 plus points in the height category and another 100 points for range category. Each player will have their own set of chips. Tossing a coin will identify who will play first or who will take its move first. The players will take turns on placing their chips on the board. And a player cannot take pass in the game. The players will only have one official score sheet, and each player will be given 1 minute to place his or her chips and write the solution and score in the official score sheet. The total score of the player in height category or the range category will be added after the time expired if someone has formed 5 in a row. The player with the greatest score will be awarded as winner of the match. The scoring system. For example, our board here, along the board, Along the y-axis of the board represents the initial velocity. Here is the initial velocity, and the number along x-axis represents the angle of release. If, for example, 5 chip, just like this one, this is the 5 chip here, the blue color one, the blue chip, is placed along 40 meters per second at 45 degrees. Here is 40 meters per second at 45 degrees here. In the circle of the board, the player must compute 4. This one is for the height category. For the height category, remember that you move 5 chips on the board, placing it under the angle of release 45 degrees, and the initial velocity is 40 meters per second. To compute for the height, first is you are going to compute for the V sub I, which is equal to V sub I sine theta. Therefore, solving for the V sub IY, you will have V sub IY is equal to V sub I sine theta. V sub I is equal to 40 and 40 meters per second, and the sine 45, and that would be equal to 28.8. And there it is, under that column of the score sheet. After computing for the VIY, you can now compute for the height. Height is equal to V sub I squared over acceleration due to gravity times 2. And this would be, take note that the VIY is equal to 28.8 divided 28.8 squared divided by 9.8 times 2, that will be 40.8. Here it is. Then you can now compute for the score on that particular move. And your score will be equal to height times the move. So therefore, your height is equal to 40.8 times the move, which is your chip number 5, times 5. That would be equal to 204.08. And there it is. That is for the range. And for the range category, this is how you are going to compute. You have another column here. You have the move, the number chip here, and you have the angle of release and the initial velocity as the given value. Then you are going to compute for the V sub Ix, V sub Iy. Then after computing the V sub Ix and V sub Iy, you can compute for the time, range, and the score. So first, compute for the V sub Ix, this column. V sub Ix is equals to cosine theta. Solution, V sub I is equal to 40, this one. And angle theta, angle of release, is 45 degrees. That would be equal to 28.8. There you go, 28.8. After computing for the V sub Ix, similar to the V sub Iy in the height, you are going to compute for the VIY, which is equal VIY rather, which is equal to V sine theta. V sub Iy is equal to V sub I sine theta, still 40 sine 45 degrees, and that is equal to 28.8. There it is for the V sub Iy. Then you can now compute for the time. To compute for the time, V sub Iy divided by acceleration due to gravity times 2. So T is equal to your V sub Iy is equal to 28.8 there. So this is 28.8 divided by acceleration due to gravity at constant, and this is constant, 9.8 times 2. The time is equal to 5.77. Why did we multiply it with 2? Because the time it takes for the projectile to go up is the same with the time it takes for the projectile from the highest point to the final position. And that would be equal to 5.57. There it is. After solving for the time, you can now compute for the range. And the range is equals to V sub Ix times time. And your V sub Ix is also 28.8 times Your V sub I again is 28.8 and the time is 5.75, rather 5.77. Therefore, 28.8 times 5.77 is equals to 163.18, and that 163.18 is placed under the range, and that's the range. Then to compute for the score on that particular move, you will have then score is equal to the range times your move, and of course here is your range 163.18 or 163 times your move, which is 5, that one here, and that would be equal to 815.9. There you go. That's how you can get the score out of your move. This one shows our detachable score sheet. This particular score sheet has a name of the player and the signature. You have the player 1, rather this one is player 2 because there are 2 players for each game. And for the height category, you are going to use this one. Next to that, for the range category is you are going to have this score sheet. You have the move, angle of release. The move is coming from the chip number 0 to 6. Angle of release, the given value, and the initial velocity, the initial value. Then compute for the v sub I, v sub ix, v sub iy, the time, the range, and the score. This one shows the actual score sheet prepared by students playing the game. You have their student 1 and student 2, player 2, and their move. This is for the chips. These are the chips used by the students. Then the angle of release, the initial velocity in the y component, the height, and the score. And the winner for this particular score sheet used by the student during the actual game was student A or student 1. Next, we have the actual same person, student 1 and student 2. This is for the range. With our assessment, this assessment is multiple choice, and they are just going to write the letter of the correct answer during the time it was used in the study. However, with regards to this assessment undergo a reliability test, and it comes up that it is a reliable one. There are 10 items related to the investigation of the height, the angle of release, and the range relationship of the 3 factors of a projectile motion. This one shows the actual game of students playing. This is a particular section using the Gomoko board and the chips. And these other 2, this one was a tournament held in the covered court. This tournament was played by 2 students from a different representative in each sections. And our references is from Barami F. et al. 2012, a comparison of effectiveness of game-based and traditional teaching on learning and retention of first grade math concepts, European Journal Experimental Biology 2012, and Pu A. and then score in 2015, game-based learning tips and trends, and Twisa L.J. Cuenca Nelborn, Tabasa Alma, effectiveness of Gomoko in improving the problem-solving skills of grade 9 students using mole concept to express mass of a substance. International Journal of Trend in Scientific Research and Development, Volume 6, Issue 3, April 2022. So that concludes the presentation of our scientific science intervention materials. Thank you for watching.